Okay, so in this video, I want to discuss explaining why gravity is what we call a conservative force. So just to review that idea, the conservative force is one where the work done by that force is independent of the path taken to achieve a displacement. That's the definition. So what that means is, if a force is conservative, no matter how you get from point A to point B, no matter what path you take, the amount of work that the force does is the same regardless of path. That's what this means. So I want to look at two examples here, and the first is, imagine on the left of this picture here, moving an object of mass m up a ramp, and imagine that the ramp has a height of h, and we slide that object up the ramp. And in the second example on the right, we lift the same object vertically upwards, the same height h. So you'll notice on the left, the height of the ramp is h, and on the right, we're lifting the object straight up to the same height h. I want to look at the work done by gravity in each case, and we're going to start with the one on the right because it's a little bit easier. So if gravity is pulling down on the object, what we can say is that the work done by gravity equals the force, which is mg, times the displacement, which is h, times the cosine of the angle between mg and h. Well, if we look, mg is down and h is up. So we have cosine of 180 degrees. We get that the work done by gravity is negative mgh in this situation. Okay. Now, on the left, a little bit more complicated, but still not too bad. Imagine gravity is pulling down on this object. Okay. So the work done by gravity in this case is going to be the force, which is mg, times the distance it moves up the ramp, which is d, times the cosine of the angle between mg and d. Now, we've looked at a couple of examples like this. The angle between mg and d is 90 plus theta. Okay, now, so we can make a comparison of these two. I don't want to look at this left side in terms of d. I want to look at it in terms of h. So let's think about this for a minute. The work done by gravity would be mg. Now, look at d in your picture. It's the hypotenuse of this triangle. The opposite side of that triangle is h. So if we think about it, the sine of the angle theta is h over d. So if I wanted to know d, I could rearrange that expression and say that d is h divided by sine theta. So let me make that substitution. So that's the same thing as d. And then I have this. Okay. Now, a little bit of trigonometry here, a little trickery. If you think about the unit circle and you think about angles, the cosine of 90 plus theta would be the same exact thing as the sine of negative theta. If you think about it, a good example would be like 30 degrees. If you do the cosine of 90 plus 30, that's the cosine of 120 degrees. That's the same thing as the opposite of the sine of 30 degrees. So in other words, I can make the substitution of negative sine theta in place of cosine of 90 plus theta. They're the same thing. Like I said, pick any angle, try it out, you can see that that works. Okay, so if we clean this up, take a look at what we have now. mg times h over sine theta times negative sine theta. This denominator is going to cancel with this. We have a minus sign here. We end up the same exact thing we had on the other side. So my point is this, guys. Regardless of whether you take a ramp to go up to a certain height, or you go straight up, or along any complicated path, we could do this for a much more complicated situation. It doesn't matter. The result is the same. When gravity does work, the only two things that matter are the weight of the object, which is mg, and the change in the elevation, which is h. If we're going from the bottom of a spot to the top, the height is all that matters and the weight. We don't have to worry about the path that we took to get there. So if you think about the lab we did with the cart, when we pull the cart up the ramp, the work done by gravity is the same whether we pull it straight up at a 90-degree angle or when we pull it along the ramp along a 10-degree angle, as long as the height is the same.